Welcome back. In the last chapter we covered terminology for probability and the rules of probability. We learned that probability is the way decision makers express their uncertainty about outcomes and events. Through the use of well-established discrete probability distributions like those introduced in chapter 5, you will be better prepared for making decisions in an uncertain environment. Here are the key learning outcomes for Chapter 5. After this series, you should understand how to calculate and interpret the expected value of a discrete random variable, apply the binomial distribution to situations, and compute probabilities for Poisson and hypergeometric distribution for applied situations. As discussed in the last chapter, when a random experiment is performed, some outcome must occur. When the experiment has a quantitative characteristic, we can associate a number with each outcome. A random variable is one that takes on a different numerical value based on chance. There are two classes of random variables: discrete random variable and continuous random variables. The value for the discrete random variable is often determined by counting. It is a random variable that can only assume a finite number of values or an infinite sequence of values such as 0, 1, 2, and so forth. In other situations, the random variable is said to be continuous. These are random variables that can assume an uncountable infinite number of values. Examples of continuous variables include measures of distance and measures of weight when measured precisely. The probability distribution for a discrete random variable is composed of the values the variable can assume and the probabilities for each of the possible values. Graphically, the discrete probability distribution can be represented by areas of a rectangle in which the base of each rectangle is 1 unit wide and the height corresponds to the probability. The areas of the rectangles sum to 1. Note, as the number of possible outcomes increases, distribution becomes smoother and the individual probability of any particular value tends to be reduced. A probability distribution, like a frequency distribution, can be only partially described by a graph. To aid in a decision situation, you may need to calculate the distribution's mean and standard deviation. These values measure the central location and spread, respectively, of the probability distribution. The mean of a discrete probability distribution is also called the expected value of the random variable from an experiment. The expected value is actually a weighted average of the random variable values in which the weights are the probabilities assigned to the values. The standard deviation measures the spread or the dispersion in a set of data. The standard deviation also measures the spread in the values of a random variable. This equation is different in form than the previous equations given for a standard deviation. This is because we are now dealing with a discrete probability distribution rather than a population or sample values. Go ahead and open Excel file sold and let's answer the following questions. Go ahead and begin by inserting a pivot table and determining the frequency of the sold variable. We can convert the frequency distribution into a probability distribution using the relative frequency assessment method. To do this, we type equals and divide by the total. Next, we'd like to calculate the expected profit from the sale of these 10 magazines. To determine the expected value, or mean, I'm simply going to use the sum product formula we used earlier. Since magazines 0 and 10 will have a 0%, those will be eliminated from the sum product. So we see our expected value is 4.95. We're also given a cost of $1.95, and we're told that Starbucks sells this for $3.49. So to calculate the expected profit, we need to calculate the expected sales minus the cost. We do this by taking our expected value and multiplying by the sales price and subtracting the 10 magazines times the cost. So you can see that their expected profit is minus $2.21 for the 10 magazines.